Hello, I'm Jongwan Yu from Jongwan TV on YouTube channel. Today I'm gonna talk about the second set of criteria that I have mentioned in the previous video. In the statistics, there are two criteria. Or actually, it is like talking about when we say best estimate and how can you define the best? Which one is the best? Or in the risk adjustment monograph published by IAA, International Actuarial Association, you can find, this definition or, like one of the code in the appendix. And like long time ago, it's not quite recent. Long time ago, one of the actuary was talking about the best estimate. So best is very ambiguous if you don't have any like criterion. And we could borrow that concept of best from the statistics. In the last video, I showed you the minimizing the mean squared error. Or instead, I used chi-square goodness fit statistics. It's the same story. So, or maybe I could, like rephrase like this. Uh, Find the parameter estimate based on minimizing minimizing the mean squared error or chi-square goodness fit. It is usually used in regression. But today I'm gonna talk about the more like popular or more famous criterion. We could find the parameter estimate based on the, the maximum value of likelihood function. We just call it MLE. And in our, like let's say loss reserving, or estimate the future cash outflow, which is a claim out goal. And in the stochastic modeling, we quite often use the MLE to justify our selection of parameter estimate. Let's look at the Excel spreadsheet. Actually, this is the same triangle that I have done in the last video. I'm just going to use the like cumulative paid loss development triangle. And key point here is, and out of all the average, arithmetic, geometric, and harmonic, and basic chain letter, which is a volume A weighted average, and I put like 8 all include all 8 link ratio to come up with the basic chain letter. Here it's not a big issue. I'm just trying to show you how the global actuary tried to use this to come up with the like LDFs, and then later it could be used the stochastic reserving model to estimate the future cash outflow in liability for incurred claims. And here I use the beta distribution. And as you see, there is a generalized beta distribution, but like for example, if theta is 1, the random variable space ranges from 0 to 1. So when I'm talking about the payment ratio, it starts from somewhere around like smaller value than greater than 0, and it all increases all the way up to 100%, which means the ultimate paid loss. So I told you this looks like similar to the CDF, cumulative density function. So here actual is I draw like this. It is just the reverse, the reciprocal of this loss development factor. And we can define this one as like CDF. And here, in order to use maximum likelihood estimation, we need to assume the distribution. That's why I assume beta. And in here, goal seek, this is the actual data, but I introduced the beta distribution. But somehow, I was given only this one data. But later, I'm going to show you how I can come up with the distribution of all of this rate ratio based on the bootstrap sampling. But here I'm going to start with the only one example, and there I could like simply calculate the sample mean and sample standard deviation, and from there using that like only one sample though, but I can get the simple like sample mean and sample deviation, standard deviation, and I can get the initial value of alpha hat and beta hat. This is the initial value that I can start from. And using here the goal seek, sorry, I have set up like, log likelihood function here for each this data point. You can look at it as a random variable of the sample of the random variable, and I plug in using beta and Bible or actually function is already in there in an Excel. I try to capture the probability density function value there, and I get the product of all those, right? Based on beta distribution and Bible distribution and initial starting the the point for two different parameters. I use goal seek. So target value here is, for example, here the product of all different like likelihood function value, and instead of minimum there is a maximum. That's what I'm trying to do to iterate this process. And I want to change the cell value for the estimate of two parameters and put it here, right? This is initial value and this is the end results. And I ran it because, if you run it again, it might change. So I'm not going to run it. So this is the results of parameter estimate based on this one sample data. So that's what I've got. And from here, I use beta inverse function here using the fitted parameter value with the given one. And this is the x value because, random variable itself is defined between 0 and 1. And I got the actual, the random variable value. And that would be the fitted cumulative density function here. And I can compare the beta is something like this, right? And viable, something like this. You can say that we can interpret this is a, let's say, payment proportion for each development period. And you say here in the first year, it pays only 4%, and beta 8.5%, viable 22.4%, which is, like occurred. So I'm not sure which one I have to choose. But as I already told you, with the, like the estimating unpaid claims based on like basic technique that reserving book, the author Ferdinand used this data, and she says, this data, let's say you cannot find a very consistent, pattern. So loss development method cannot be used. That's why she kept on using the sample data to run it for the deterministic models from loss models to all the way up to Berkey-Sherman and try to illustrate what those models, like advantage or disadvantage. So this data doesn't look, and I'm not going to conclude this one actually, right? Which one is better? But what I'm trying to tell you is that this is the most popular and probably the starting point to move into the stochastic reserving for the LIC, or liability for incurred claims based on the parameter selection, which is one of the like most important assumption in our like cash flow projection model. And that is a very, very powerful and like probably the most popular criterion to get the parameter estimate in order to do my stochastic reserving to predict the future like distribution estimate of future cash outflows based on maximum likelihood estimation technique. So I simply just try to demonstrate like two different criteria, including previous one and today's one. And please remember, it is quite easy to implement in your, like actuarial practice in the future. But later on, I'm gonna expand this model to get the distribution of LDFs, right, in the bootstrapping like sampling. So virtually you can create like, like 10,000 or 50,000 or 100,000 different LDFs distribution. In that way, out of, like prediction error, you can quantitatively measure the estimation error. So this is the starting point. And next video, I will probably show you that, what kind of adjustment or how much adjustment the actuary usually do against the paid loss development triangle or case outstanding figures and or even like LDFs. And that's one of the, like parameterization process. So we just call it, like best assumption, actuarial assumption, but I want to call it more, like specifically, it is just the like, like parameterization process in our stochastic modeling. But this one is only for the paid loss, but you can apply it to the, like future premium, like cash inflow as well. Later, I'm gonna show it. But today, uh, I hope this is very helpful for you to understand it, the basic concept, and probably like to help you understand better for the stochastic cash flow like modeling later on. Thank you very much.